Okay, welcome back to our discussion on compound interest. This video is actually optional. If you're struggling with the last two questions on your homework, then feel free to watch this video. Otherwise, if you think you understand, I think you have enough background that you might be able to finish the last two problems. But again, just so you know, we're going to use compound interest. The formula, I'll write it down right now. Recall, again, I would suggest that you might want to pause the video and see if you can write down the formula without looking before you look. Right, but let's go ahead and write this formula down. So the formula, if you recall, is we have A, and it's the amount of the investment after so many years, the principal. It's going to be 1 plus the rate over n, and the power would be n times t.
Thank you. There it is. Yep, thanks.
Right, so in this example, our A, well, let's find out. So here, the deposit is $15,000. So that's our P. So P is $15,000. Our rate is also here. It's 13%. So that's R. So 0.13. They said monthly, which means that our N is equal to 12. And so far in this formula, I have a P, which is 15,000. I have the R, which is 0.13. I have the 12 here, and I'm missing the T and the A. So it looks like they didn't give me enough information. Then the question says how long, so that means they're asking me for the T. They're asking me how long. So that's the question, is what is the time? And so that means that somehow this problem already tells me what A is. In the words, A should already be given. And so here the key word to notice is that they want the deposit to double. And so if it's double, that means, well, if I started off with 15,000, that means after it doubles, A should be 30,000. And in fact, that's exactly what we need to plug in here. So we have the following equation. We have 30,000 is equal to 15,000. We can simplify this number or leave it like this. I'll leave it up to you. I think I'm going to go ahead and plug it in the calculator just so that it's a little bit nicer to work with. And now we can sort of start solving here. We want to get to t. We want to solve t. And notice that t is in the exponent, so this is where that natural log trick, or that taking the natural log, is going to work. But before we do that, we have to get rid of this guy, the 15,000. So we're going to go ahead and divide by 15,000 on both sides. And we see that 30,000 divided by 15,000, we know this is 2. This is gone. And then when I work this out on my calculator, 1 plus 0.13 divided by 12. Actually, no, I didn't work it out. Sorry. So I'm going to leave it like that the whole time, just so that you guys can see what it looks like. All right, here we go. So I want to get to the t. So this is what we did in our last problem. We took the natural log of both sides. Remember that means is that I'm taking the natural log function, and inside of the natural log function, I'm putting these two things that are equal to each other. So instead of the one on the left, I'm putting in the 2. And on the right, I'm putting in this 1 plus 0.13 over 12 to the 12t. And the reason we do this is we want to recall the rule that says, again, here's my thought, that when you have a log of a number raised to some power, any base, that power can be brought down to the front. And that's sort of what I want to use here. Because on the left, nothing really changes. I have the natural log of 2. But on the right, this power is 12t. And that's exactly what ends up coming to the front. So it's 12 times t times the natural log, with the input of 1.0.13 divided by 12. All right, so now I want to get t. That's the goal. Let's solve for t. So all I have to do now is just divide both sides. Well, I want to get rid of the 12, so let's divide by 12. And I want to get rid of this natural log, so let's divide. That's going to be a number that you can plug in on your calculator. And then here we do the same thing on the left. And now you just, hopefully the calculator is not too difficult for you to use. Again, if you have questions, come see me in class, but I get that this is approximately 5.36 years. And so they asked us to find t. So the question was, how long would it take for the deposit to double? It would take approximately 5.36 years. I always think it's a good idea to answer these word problems with words, because you're trying to explain. And if you ever had a job and you were asked to solve this, you wouldn't just say 5.36. You would actually use the words. Well, anyways, let's do one more example, and then hopefully this will help you with your homework. So again, I would pause the video here, see if you can write the formula without looking. Recall that the formula is A equals P1 plus R over N T. So again, we're looking for the key words. So the one thing that always sticks out at me right up quickly is the percent. So they give me the R, so R is 9%. I see 5 years, so I know my T is 5. I see compounded daily. Compounded daily. That means N is 365. And so again, it seems like I'm missing A and P. What are these two? And so the first thing, so now I have to read this a little bit carefully. It says, what principal should be deposited? They're asking me about the principal. This is what I need to know, which means that the other number in this problem, what principal should be deposited at 9% compounded daily to ensure the account will be worth $10,000 in 5 years. Well, in the future, that's what A stands for. This is the $10,000. And so then now that I know exactly what all my variables are, now I just plug it into this formula, into this model, and then I solve for P. So A is 10,000. P is what I don't know. The rate is 0.09. The N is 365. And then I have to multiply 365 times 5 up here. And so after I work, so the right-hand side, this expression that I'm underlining, this is the expression that I can plug into my calculator right now, and I actually would. And so I get 10,000 equals P. And again, I don't round off to the very, very end, so I put 1.568225193. And then I divide. Notice I want to solve for P. Our goal is to solve for P, so I divide both sides by 1.568225193. So I'm going to go ahead and write it, but as I write it, go ahead and plug this into your calculator. And hopefully you get the same answer I did. So P is approximately $6,376.64. I rounded off here. Okay, and so the question is, what principal should be deposited? We should deposit $6,376.64. All right, good luck with your homework.